Okay, sweet. Okay, so we're back. Let me just pull up my calculus stuff. As per usual, we'll go through our Anki, and then we will dive right into our the practice that we'll be doing for the day. Okay. Yeah, might end a little early tonight. These days have been shorter recently, I know. But, yeah. We'll see how it goes. Okay. Oh, so this is the one that I need to learn. Okay, secant is for a given curve, 2 points on a curve, and it is the average of the slope during that period. And the tangent is the instantaneous slope 1 point. Okay. It has to be not undefined. It has to be able to be evaluated. It like f of x at x equals whatever needs to be like exist, and then also the limit has to equal the input, or the limit has to be the same as the input. So if the limit goes to, or sorry, the evaluation of the limit and the actual value has to be equal. So if my limit is like 4, if I substitute 4 for like x for 4, or 4 for x, or sorry, x for 4, then I will get the same thing. Yep. Okay. I think we'll just get started on or continue on the exam then. Okay. Okay, so see if we can get a solutions. Oh, that's is it MIT? It's probably gonna have me. Okay, I think I'll just try to upload this to ChatGPT and see if it gets them all. That's funny. It was determining whether or not I was um, violating academic honesty. Because it does say in the exam itself that like you're not supposed to yeah, you're not supposed to use any calculators or computing devices. Okay. So I don't know how to so I think that is the case that we got that, and it, I mean the left hand, right hand uses the same. So actually, so this checks the left hand and the right hand. Oh, actually, no, that's fine. So I was wondering, oh, maybe it's the case that the this was not correct. Anyway, but the three that we had were that's not undefined, that it's or rather, so I think this is checking to see if we have a discontinuity on the left side or the right side, whereas the 3 problem check that we did for continuity was to determine whether or not that specific thing was continuous right there. So I think it's reasonable that we check both sides. Let's add something with that though. So I'm going to open up a different one. Okay. Looks like I'm getting a little bit of the same there, so that's fine. Okay. So asymptotes. Asymptotes. Okay, begin stating regular text unless otherwise requested otherwise. How do you find asymptotes on a for a function? Okay, so I'm just recognizing now that it's probably the case that going straight to the test after like having a initial run at the concepts would probably been best. And then additionally, it is nice that I found this like practice final 2, so I can take it and this will be what I like determine if I learned things correctly, right? So, um, yeah. So if I would have taken an initial, or I did my initial conceptual search, and then I looked into this exam and just went like question by question. Well, I don't know. I think I've also done pretty good because it's not like I've wasted much time. Obviously, I could have gone much faster if it was just like if I was just offline, right? But I feel like it hasn't been too bad. I sort of collected ideas that I didn't recognize or didn't know, and then attacked those. I guess both approaches are probably fine. And since my goal is just to merely understand and be able to be competent in this area, then I think we're at a fine level. Okay. Okay, we'll just continue. Okay. Okay, so let's actually dive into this a little bit. So 3 types of asymptotes. So the vertical ones are where we approach infinity. The horizontal ones is where we approach a particular y value as we increase in x. And then for slanted ones, we're approaching a particular slope as x increases. Yeah. Okay. Identify values of x where the function is undefined. Okay, that makes sense. Okay, so this would be this is a discontinuity. Well, I guess probably most asymptotes are have discontinuities. Actually, except for the slanted ones, those probably don't have discontinuities because we're just approaching a slope. At least that would be my intuition. Is it correct to say that slanted asymptotes do not cause discontinuities? Yeah, hell yeah. Okay, so horizontal asymptotes are probably the same as well. And that would be correct for horizontal asymptotes as well also, question mark. Okay. Perfect. Oops. Oh, okay, now for horizontal. Okay, so let's see, before looking into the vertical or horizontal, that I could exert some cognitive effort to figure out. Actually, horizontal one seems self-explanatory, so I just have to take the limit at infinity, and rather than the y also, or the output also hitting infinity, it's going to hit a value. So that one is reasonable. I just have to take the limit at infinity. Though I actually don't know how to take the limit at infinity, I don't think. Yeah. I'll have to write that down. And then for the slanted ones, we'd be approaching a particular... So we would be like, as the limit, or as x reaches infinity, y would also reach infinity for slanted ones. It might go faster or slower, but it'll reach infinity. But it will approach a particular slope. So I'm not sure. So maybe we take... yeah, I'm not sure. I guess you could, like, one way you could sort of derive it would be to just like repeatedly take the slope and see if it converges on a point as the values increase. Or you could alter the function such that let's see. Well, okay. So if a derivative gives us the instantaneous slope at a given point, then we could hypothetically take the limit of a derivative at infinity to find the slope it converges on. But I'm not sure. Well, yeah, I actually still don't know how to do the taking the function at oh, okay. So a clear sign of a asymptote is that for a given thing, if we take the limit of it at infinity, it's going to be a number instead of infinity. So for a horizontal asymptote, that's going to be output as y, right? For the vertical one, we just actually have a discontinuity, so I don't think it follows that. Yeah, we just have a discontinuity. So that is different. But for the slanted one, it's going to be approaching that slope. So as the derivative, if you take the limit of the derivative of at infinity, then you arrive at the slope. Okay, let's see what we have here. Okay, divide the numerator by the denominator. The numerator by the denominator using a polynomial long division. If the degree of the numerator is exactly one higher than the denominator, the quotient, ignoring the remainder, is the slant asymptote. This describes the function's end behavior as x equals positive or negative infinity. Okay, find horizontal asymptotes. Evaluate the limit of a function as x approaches infinity and negative infinity for rational functions. Compare the degrees of the number of the denominator. If the horizontal asymptote is the ratio of leading coefficients, if degrees are equal, or y equals 0 if the denominator's degree is higher. Okay, so it looks like we also have, we're also dealing with fractions for both of these. Okay. So I'm definitely going to. So we need to know how to take the limit of a function where the limit's infinity. How would I take the limit of a function as x approaches infinity? I'm not sure how that would work. So is it the case that I just substitute larger and larger numbers to see what the output converges on, or how would that work? I'm not sure about the process of taking the limit there. Oh, okay, that's interesting. So as x squared approaches infinity, this becomes 0. Interesting. Okay. For I think this weekend I'm gonna try to do like a multiple hour session to see if I can just push through the last, or I see how much I could push through for finishing calculus, because I am excited and interested in starting up statistics next. Yeah. So there's that. I think I might end a little early tonight, but I think we're at a good spot. So we'll need to figure out. I guess we'll just continue from here next time. I'll see you guys later.